Okay, in this video, we're going to talk about the sandwich principle and some special limits. So, the sandwich principle, or sometimes called the squeeze principle, says the following. Suppose you have three functions f, g, h, and g, the green function here, is squeezed in between the f function below and the h function above. And suppose the limit as x approaches c of the bottom function f and h is equal to L. Okay? So this is L here. This height here is L. Then what happens is the limit as x approaches c of the squeeze function is forced to be equal to L. As you can see, right? The function is squeezed in between f and h into L. So the ant, if it's in here, gets squished, right? Or squeezed. Right? So let's apply this to this following example. Show that the limit as x approaches 0 of x cos x is equal to 0. So then we must have, so we know that cos x first is bounded by minus 1 and 1, right? Now if you multiply by x on both sides, right? We have minus x is just equal to x cos x plus equal to x. Then first we have the first right criteria satisfied for the squeeze theorem. Now second thing we need is that the squishing functions to the bottom and left is as x approaches 0, right, is equal to 0. So therefore, by squeeze theorem, we must have that the function in the middle, right? In this case, representing the g function, the limit as x approaches 0 of x cos x is equal to 0. Okay? Now, just a couple of special limits, which we're going to use now, just assumed to be true, but we can prove this later on using L'Hopital rule. First, uh, so the special limits are in fact trigonometric limits, special trig limits. The first one says that limit as x approaches 0, sine x over x is equal to 1. And limit as x approaches 0, 1 minus cos x over x is equal to 0. Okay. So in fact, one can be shown through a type of geometrical sandwich argument shown in the textbook. For the second one, you can actually prove using the first one. Okay, over here. All right, so that's it for this video on sandwich principle and special limits.